Hey everyone. We can start lightning talks, I guess, with a little bit of being late, because I think if there's the third guy in here who submitted the lightning talk, please come. So yeah, we're getting started. I actually have two quick talks. The first one's gonna take like literally 5 minutes. Basically, it's gonna be about Nix. I love Nix personally. I find it great for everyday use cases. But like, what is Nix exactly? It consists of a few different parts. The main part of Nix is being purely functional programming language. Some also call it a package manager, but that's not true. The true name of that should be a build system. And we've cut off the word. And that's also the operating system. So NixOS is based on Linux. It's really great distro, which is using those configuration files in Nix language. Basically, why some people call it a package manager and why that's wrong, because in Nix, there's a thing called like Nix cache. And basically, you can use Nix to pre-build a package for your OS with Nix, and you can use Nix cache to host that. And basically, you can get the packages of the web easily. But actually, under the hood, it's still a build system. On the right side of the slide, you can see an example Nix flake. A flake is more complex in Nix functionality. Basically, it allows you to turn any GitHub repo into a package, sort of. As you can see, it's very simple to use. It has a very simple and nice syntax. And this screenshot also shows the idea of Nix. So you define your inputs and you define your outputs. And you can simplify everything to such a simple approach as if you use the same inputs, the output should always be the same. So if you build a package with Nix using the same input, let's say your colleague from work is also building the package with Nix, you will have the same checksum on the file, basically, which is also useful in security perspective, because when we have few public Nix caches, so we can compare the checksums of packages from them, and if one is wrong, then possibly something is wrong with the build server on that. So it's easy to verify your system, whether it was tampered with. But yes, why is it cool as a package manager and a build system? Because it allows for static compilation with basically everything. Nix packages currently contain above 90,000 packages, which is the biggest repo in the world, basically. The cool thing about Nix is also cross-compilation. Let me see if I can use terminal. Will it look like? OK. So basically, let's move to WSL. And I can, I had this in here. There's a thing where in Nix, I can show you how it works. Basically, cross-compilation, you can check that with rep. And basically, those are all your options for cross-compilation. So that's quite easy to build software for even M1-based Macs, for Darwin-based systems. It's really great to do that with Nix. And as you can see, Nix also works under WSL, which is also great. Oh. OK, back to the slides. Also, it's easy to set up that binary cache. You can do it yourself at home. You can also go further with a thing called N-user repository, NUR, which is also great. And because it's a build system, you can apply such called overlays, which are basically patches to a software. And you can do that without forking the repo. You can do that locally, which is also a nice, easy-to-do approach, so you don't mess with the mainstream of the source code of the package. And you can apply your own tweaks and share them further down the line. On the side, you can see also another feature of Nix, which is called a dev shell. And that's one of the coolest things in Nix, because it's reproducible and you always have the same output of that. It's also helpful for developers because you can have the same development environment as your friends do. You will ensure that all of you use the same version of library and so on. Even if one of you works on Linux, the other one on Mac OS, and the other one is using WSL, you can ensure with Nix that everything's going to be fine with such a simple example like of a dev shell like this one. This one is using a pre-made list of packages in Nix, basically. So I can go to my own personal project. I created Rednix and Rednix OS. It consists of basically 4 different parts. So those are 2 repos on GitHub. The one repo is the main repo, and it contains a flake, so we can import that into already existing Nix system, and that provides a package set. I can actually show you that. These projects, Rednix, and let's go packages. Okay, so basically that's the list of packages, and everyone can import that to someone's project, basically. Those are pre-made lists of packages and also groups of packages, which is also a cool thing about Nix, and show you that in a moment, because it also has so-called dev shells, as I mentioned a minute ago. And basically what a dev shell is, so let's say Snow Crash. Not found command. Okay, great. But let's go with Nix develop .#rcl, because that's the name of the package group I'm using in here. Yes, git is dirty. Okay, great. And now I can go. Bam, I have Snow Crash. And you can see that it's stored in the Nix store, which is basically where Nix stores everything. So you don't have problems like with different Linux distros. Like there's like Chimera Linux, which is reusing the user land from BSD systems. And that can be problematic. So Nix came out with this idea to use /nix/store to store everything. And the dev shells are temporary. So I can exit that and boom, it's gone. But the file is still in my file system. It just changes the permissions, so I can use it only with Nix shell as a temporary shell, basically. In that project, I also have a NixOS container, which is another useful approach, but that's limited only to the NixOS users, because on NixOS, you can use systemd nspoke containers and heavily customize those with a configuration file. And such configuration looks like this, basically. Okay, so you can use the same modules as the main NixOS in your NixOS container, which is really nice. You can set up everything in a single file. You can import packages, lists, and so on, which is very useful for making containers under NixOS if you want to have a temporary environment with a different user and so on. That's great. And the other project I'm having, which was a derivative from all of this, is Rednix OS, which is basically reusing Rednix, but also providing you with an option to build an ISO. Suddenly, like yesterday or 2 days ago, there's an update to Nix which messes up fetching from a URL. So it's not building properly as of right now, but the hotfix should be there before the weekend, as they say. And that should be done. So basically that's the Nix, and I really love it, and I just wanted to show the Nix to the world. And if you want to check out a few things about Nix, here's the QR code to Pastebin, because I have links to my projects there. And also on this slide you might have noticed that there's also a little link, because a Flake also offers one another thing, which is also cool. And you don't have to have Nix installed. You can use Nix Portable. There's a repo on GitHub. Basically, you can just download a single static binary to your system, and then you can use something like Nix shell. Actually, let me check in history so I don't mess it up. Nix. Okay. For example, that. And as of right now, I've already downloaded all the inputs for that package, so you won't show the process of downloading everything. But basically, it fetches the data from the Flake file from GitHub. And basically, once you place a Flake file in your GitHub project, you can turn that into a package just like that. And let's go with project --help. You can see it's working. And also, the shell in here is similar to the dev shell I've shown previously. And now it's gone. And the other cool thing about Flakes I also want to show you is when you can compare packages and see their inputs without actually installing them. So you can have something like that, which will basically fetch the information from the Flake from GitHub. You can see the inputs from that, last modification information, what that is actually, the path to that if I have it locally, the inputs I've added recently. So like I have Nix packages, obviously, Flake utils, basic stuff. But I can also go to the second project I have, which is derivative of the first one. And you can see actually that I'm importing Rednix. So it's cool. And that would be basically this about Nix. Thanks for your attention. I just wanted to promote Nix because it's very cool and I think everyone should use Nix. And I hope so it happens one day. How many time do we have? Yeah, basically. 15 minutes? Okay, I also prepared the second talk, which is more interesting to the wider audience in here. Basically, WSL basics. I know that some people use, who in here does use WSL on a daily basis? 1, 2, 3, 4, okay, great, 5, okay, great. Basically, the WSL is Windows subsystem for Linux, and basically, it consists of few main components. There's a session manager executed in the user mode on the Windows side of things. There are 2 new drivers introduced, that's LXSS and also LX Core, which are basically Pico process providers. I explain that in a moment. And that Pico process are starting whenever you start a native Linux process. And as of WSL2, they're using virtualized, customized Linux kernel running under Hyper-V. And it was customized by Microsoft to ensure that a Cisco layer compatibility is working fine and improve overall file system performance because, you know, it's a Hyper-V VM, so it's heavier than just a Pico process. So what Pico processes are, basically, they're associated with Pico provider kernel mode driver, that LX Core and LXSS stuff. And they have 2 layers of implementation in Windows. So there's like minimal processes. So that's when there's empty user mode address space, and also Pico processes. So minimal processes, but they're also associated now with the kernel mode driver, the Pico providers that launches everything. Back in the day, because Pico processes were widely used with WSL1, as of right now, they're not as widely used because of the architectural change in WSL. But in WSL1, the host OS didn't even try to manage user mode addresses space inside the Pico process. The Windows kernel was passing all syscalls and exceptions from user mode of Pico process to a Pico provider to handle everything. And Pico provider was starting at a boot time with a Windows kernel, and they were exchanging interfaces. So basically, function pointers for kernel were exchanged to call when dispatching a user mode syscall in WSL. And also, as an example of that, another one, the kernel provided pointers to a Pico provider for actually creating Pico processes or threads. As I mentioned, they're not actively used in WSL2, and interaction with the kernel is somewhat different. They're rather used for file system interaction in WSL2 because they've introduced that real Linux kernel under the hood. And basically, there's a little side note. When a program is run, Linux subsystem driver requests to a Windows kernel to run process, and it calls a function called zv create user process. That's from the Windows driver kit. How the syscalls work basically, so the flow is like there are marshalling parameters, so they're moving parameters into the CPU registers. Then there's a syscall with a trap to transition from a user mode to kernel mode to actually make the syscall. Then there's a return from the system call with another special instruction to return back to the user mode because two kernels have to talk to each other. And then the user mode from WSL checks the value returned. And that's using AlexSS driver. Also, as a side note, a very interesting fact is that WSL is implementing pipes differently because Linux pipes and NT kernel pipes are working kind of different. So it has somewhat a re-implementation of that. But it still relies on very primitive NT functionalities, so like data structures and synchronization. And shed yield from Linux is mapped basically one-to-one to the W yield execution. That's also from the Windows driver kit. Also, how the file systems work. So in WSL, they're using virtual file systems. So you can have multiple file systems to coexist with each another. So by default, WSL will use ext4, and Windows obviously by default it's NTFS. And also that VAFS implementation is implementing another set of system calls for file system operations. And they're using data structures, and for example, those are index nodes, so basically inodes. Basic stuff, information about file system, objects like file type, permissions, size, last modified, and so on. And also directory entries, because they're using a directory entry cache to represent the file system namespace. And there's that D-entry thing in memory, so there's no physical store because that's a virtual hard drive. And that entry contains a pointer to an inode for the file, basically. And also, it also introduces the special file types like device files, socket, symlinks, and so on, because it's different. Also, with file systems, the WSL file system has to perform the following operations. So it has to translate Linux file system operations into Windows kernel operations, as I've mentioned, that interchanging operation between the kernels. It has to provide special file systems, so that's pros, fs, drive fs, and so on. They're explained at the bottom how they look like. And they have to provide access to Windows volumes, which is turned on by default in WSL, and they're auto-mounted by default in WSL. And they also have to provide a place where Linux system files can operate normally, allowing for file permissions, symlinks, and so on. And that's where the AlexCar driver is used. But what's next? Actually, I have only 5 minutes, so sorry. For the people who are defending the Windows endpoints that might have WSL installed, there are two places, actually. Okay, it's refreshed. There's basically this path. So see users, that's your username, app data. Let me just go there so I can show you that. Okay. Let's change my username. Okay. Okay. And basically, that's where the exe file for the WSL is stored. So whenever you launch that in a partial CMD, that's what it was called. Also, they're mapped under WSL and distro name. So when you go to your terminal, let's go WSL $Ubuntu. As you can see, I just went into the Ubuntu file system from PowerShell, and the more details are found under this registry key. And basically it looks like, let me just get a new one, get child item, here we go. Okay, so it looks like this in the registry. So you have information where the VHDX file is stored. And that's very useful for forensic perspective because you can import that to autopsy, for example. You also have information whether that's WSL 1 or 2, also the name of that, and that's pretty cool. But the exception for that is WSL system distro, which is quite complex because it looks like this. And there's WSL system is stored under the program files WSL system VHD. And what's interesting about it is it's the distro that's handling the X11 port forwarding for your main WSL. However, there's also the other side of everything. So basically, you can go with WSL-u-root, and without asking for password, you just get the root on the WSL, which is quite cool, and it automates the Windows file system onto that. There's also that I think you can execute the binaries from Windows, and if you have WSL enabled, you also get bash enabled, and both of those can be used basically for AWL bypassing, and the WSL stuff can be also combined with -u-root and -d to change the distro it's using for execution, because basically, do I have it somewhere in history? Okay, let's go with this. Because the bash on Windows is by default using the default WSL distro, which can be found using this one. So the one with asterisk is your default one, and as you can see, the bash is using the Ubuntu one. So it's pretty cool. Okay, just what's next? Stay tuned because I'm still researching that, and I hope I'll manage to write a blog post on it. So thanks for your attention.